So for my final build in this mechanical engineering segment of the creative engineering class, I reinforced my prototype in a inverted flower pot where I cemented it in place to make it sturdier compared to the last time where I just inserted it into a heavy piece of metal. I also added this piece of cardboard in here that stops the string from slipping down, and I added these foam sheets in my wooden base to hold the aluminum mold better. So, yeah, my prototype is functioning good, and now we're going to test it with this. Still the same half-eaten ice cream from the last time, but slightly used. So, solid frozen, it's hard to consume. Yep. So we're gonna put in our device, add a little bit of water. Now we're just going to spin it gently to avoid spillage or whatever. Okay, there's some more ice on the outside of the ice cream, so maybe it's good to go. Okay, it's still not soft enough, but on the sides, it's easy to chop off with a spoon compared to when it was fresh out of the freezer. So, yeah, it works. I will revisit my requirements and constraints for building this project. So let's start with the essential and the non-essential. So for both requirements of both categories, I had three. So for the essential, I had the need to hold for water and to make a shake motion. And for the non-essential, I thought of the idea of using a mechanically powered, so it can be used without the power of electricity. So for the need for hold water, I had two options, using an aluminum basin and using a bigger tub. So obviously I went with the aluminum basin because aluminum conducts heat efficiently, so it's better to use than any other bigger tub. So for the shake motion, I had the idea of using a tiny rotary motion, which should be powered by an electric motor, but since I have no technical grasp for making a mechanical lever, I did not go with this idea. Instead, I used my other idea using a pulley, which should be pulled from the left and the right to make a clockwise and counterclockwise motion, which also achieved the non-essential requirement that my device would be powered mechanically. And for that, I had the ideas of using a mechanical shaft and a tape measure mechanism, but I did not go with that because the pulley from the left and right is efficient enough. Now I will demo using another pint of ice cream. So aside from that half-eaten ice cream from earlier, I have this pint of Rocky Road, which will be also tested. So for our test, it's still hard. So to cover more surface area in the rotational motion, I'm gonna put it so much water. It's still a little messy, but we could work with that. Okay. What's this? Wow. So plus submerged on this side, so we're gonna try it here. It's softer now. So one of my peers asked in the comment section of my prototype if I could use this device to thaw chicken breast. So to test that, I got the best test thing, beef tapa. So the other one, I'm just gonna leave it here on the surface to thaw on its own, and the other one, I'm gonna put it in my rice. So let's add a little bit of water. Until it's submerged, I guess. And let's keep spinning. Now the rotating motion or the circular motion creates a uh, something like the flowing water or running water, which is another method but consumes a lot more water than this method. Wow, the hand is definitely full of water. It's a little flexible now, so I guess a little bit push to make it a lot softer. Okay, so you see here, it is now soft and with a little bit more spinning or more time here, it would be defrosted. While the one I left here is still pretty solid. This one. So that's it. So I hope you guys are all doing it fine.